All right, friends and neighbors, welcome back. Today we are covering Chapter 18, IP routing in the LAN. And I think you'll like this one because we're going to do routing in so many different ways. So off we go. So in this video, like I said, we're going to do so many ways to route. And what I mean by that is that we're going to take all kinds of different devices and figure out how to use those devices, whether it's a router or a switch, to route. And we're going to take routers and figure out how to switch from them. So kind of cool stuff. The exam section that we're covering is the role and functions of routers, and then layer 2 and layer 3 switches. And of course, we're going to configure and verify VLANs across multiple switches. Now, we're not really going to do that as part of the chapter, but that's the section of the exam. And then certainly inter-VLAN connectivity, because we're going to route between VLANs. Now, I'm not going to build really large topologies on this. I'm just going to show you how to do it from various devices, but you'll get the idea. And of course, we'll do the do I or do you know this already questions and the look ahead. Oh my goodness, such a long list of things, right? So this is all the stuff that was in this chapter. So hopefully, if you're going down through this list, you'll understand after reading the chapter and after doing this video, and maybe after doing some of the demos, how to do all of this, this stuff after you're done with the chapter. So there are essentially 5 ways to route covered in this chapter. Now I'm going to add sort of a 6th topic, the ether channels. We're going to return to those, right? We talked about ether channels a while ago, but these will be layer 3 ether channels. Now the first one is depicted on the graphic on the side of me here. And I'm not going to talk too much about this. This is not actually a demo because it's just straight up routing. So if you have a whole bunch of networks, what you typically do, right, is you hook up a router between those networks, and that's how you interconnect to folks on a different network. Now, if we collapse that and we say, oh, well, the 2 switches could be replaced by 1 switch with VLANs, that's what we would do. And that's, sort of the migration of this. But what that means is that every VLAN would need a router interface. And that's kind of expensive in terms of interfaces. So that's not usually what we like to do. So the other routing approaches that we take in this chapter are going to be sort of addressing that, right? Or what are other ways to handle that? Now, it's highly situation specific, right? Depending on what you're doing, you'll adopt one of these different strategies. But this first stop is probably a little too port expensive to apply in very many places. So the first one is that we're going to configure router on a stick. Now I've done videos on this before. Actually, I've done videos on almost all of these topics, and I'll try to link to as many of them as I can. But essentially, it's exactly what it sounds like. You're going to use one router interface, and you're going to send that down to a switch, and you're going to trunk from the switch to the router. So the switch is going to have a configuration on it. It's going to be a trunk, and you'll have multiple VLANs on the trunk. Remember, don't put your trunk in a VLAN. And then our encapsulation will be .1Q. That's our default. And then once we get to the router, the key here on the router is that you're going to connect to the physical interface, but we're not going to configure the physical interface. We're going to configure what we call sub interfaces. And so each one of the sub interfaces is going to be tied to a VLAN. So just like the trunk line has VLAN tags, and so you're multiplexing all of those VLAN tags across that trunk line, we're going to do the same thing, but the way that we're going to separate them at the router is with those sub interfaces. Now there are a couple of ideas here. If you are setting up a bunch of VLANs, it's not required, but it's a good idea to number your sub interfaces based on the VLAN to which they are connecting. So for example, F0/0.10 will be tied to VLAN 10. Now, if you add the keyword native after the 10, what you're telling the router is that VLAN 10 is now the native VLAN. If you put an IP address on the physical interface, which is not normally what we would do, but if you put an IP address there, then the assumption is that that is where the native VLAN is going to connect, right? Unless you changed it, as we just talked about. Now, troubleshooting these things usually comes down to verifying your config, right? Stepping through everything. So let's take a look at that right now. So these are all the things we're going to talk about today. This is where we started, right? I would have a couple of switches. Each switch would have a network connected to it, and then we would take these switches and move to a switch with multiple VLANs. And here is our router on a stick configuration. So what I'm going to do now is I'm going to just build a configuration on the switch real quick. So we would say enable config t, and I'm going to say int f0/1, and we'll say switch port access VLAN, I don't know, 11. And we'll do this a similar thing with f0/2. We'll say switch port access VLAN 12. Now, if I do a show VLAN, and this is one of the other things that the book talks about a little bit, right? We have this VLAN configuration, but now we also have an interface called VLAN 11 and VLAN 12, and we have a different set of commands here. So what we have to remember is that we can talk about a VLAN, right? We can say we have the VLAN itself and we get a certain set of commands there, but we also have the interface for the VLAN. And you can interact with these and cause problems for yourself with both sets of commands. So there's the VLAN itself, there's interacting with the VLAN, and then there's interacting with the interface for the VLAN. Okay. So now what I'm going to do, oops, I think I'm connected to 24 down there. I am. It is 24. So what I'm going to do is I'm going to say config t int f0/24, and I'm going to say switch port mode trunk. And this enables the .1q tagging on there. So this interface has now been made a trunk. Now, how do we send that up to the router? Well, what I'm going to do on the router is I'm going to say int f0/0, that's the router physical interface, and I'm going to say .11. Now here I'm going to give it an IP address, and maybe we'll do the VLAN first. So I'll say encapsulation .1q11, that's the VLAN, and I'm going to say IP address, I don't know, 192.168.11.254, just like that. And then I'm going to say subinterface f0/0.12, and I'm going to do the encapsulation for 12, and we'll give it an IP address. Okay. Now, if I do a show IP route at this point, we can see that I have both networks and they're connected to the subinterfaces, and that is how you do router on a stick. Now we could do one more thing just to show you that, you know, it actually works. Maybe what we'll do is we'll connect the PC to VLAN 11. So while that interface is coming up, we'll give the PC an IP address like this, and then maybe we'll do 11.1 like that. Okay. So now, as long as the interface comes up, there we go. We'll give that a second. And I'm just going to try to ping my default gateway. All right. Now what this is going to do is that it's going to go out that trunk line. It'll be tagged for VLAN 12 or VLAN 11 in this case. It'll go up to the router, and then the router will take a look at the subinterface, strip off the tag, and off we'll go. And there we have it. So that's how that works. That is router on a stick. Now case number 3 is sort of moving beyond that. Right? If I say that I have, I don't know, 20, 30, 40 VLANs, then I'm asking that one interface on the router to do an awful lot. So at some point you move from wanting to do router on a stick to saying, well, let's work with the sort of next generation stuff. Let's work with layer 3 switches. And what we're going to do is route between VLANs using the switch itself. And so that's the depiction that we have down here. So I've got a couple of networks, and notice that while there's still that switch in there, there's no router at this point. So we're going to turn on IP routing on the switch. So the switch will understand not only the layer 2 stuff, but it'll understand the layer 3 stuff as well. So it'll understand VLANs and MAC addresses and Ethernet frames, but it'll also understand what networks we're working with. The trick here is that when you add ports to a VLAN now we're going to go into the interface for the VLAN and give it an IP address. So let's take a look at that. So here we are in scenario number 3. And what we don't want to do is confuse what we're doing, right? We're still going to do the normal switch stuff, but then we're also going to do routing. So we'll do the exact same thing. So I'm going to say int f0/1 switch port access VLAN 11. And then we'll go to f0/2. Now notice this is also a different chassis, right? This is a 3560 in this case instead of a 2960. And that means it's a multi-layer switch or a layer 3 switch, and so it can do this routing stuff. So I've got my VLANs. I've just got a port in each VLAN. And because the PCs are connected to them, we can't talk between the PCs, right? So let's give them some IP addresses. 192.168.11, oops, 11.1, and the gateway 192.168.11.254. Now, interestingly, the PCs have no idea that they're not talking to a real router, right? It's just an IP address out on the network, somebody to help them out. We'll do the same thing here. So 192.168.12.1. 192.168.12.254. Now, if I was just doing a straight up routing or router on a stick, right, there'd be a router somewhere and I would give that IP addresses, but I'm not going to do that now. What I'm going to do instead is first up, I'm going to say to the switch, I want you to do some routing for me. So I'm going to turn on IP routing. There we go. And now I'm going to say int VLAN 11. Notice the change to the command. I could go to VLAN 11, but the commands are different. And now I'm going to do IP address 192.168.11.254. Whoops. And I'm going to go to VLAN 12 and 12.254. Okay. Now, because I turned on IP routing, I have a whole collection of commands that are now available to me because I'm also getting layer 3 commands. So now if I do a show IP route, and this is an important distinction, right? I have directly connected routes, but they're connected to VLAN 11 and VLAN 12. Well, let's see if our PCs can talk to each other. I'm going to ping 192.168.12.1. There we go. All right, so that works. Now, because it's a layer 3 thing, we can also do traceroute. There we go. And so that behaves just like it would at layer 3. So that is switch virtual interfaces and routing with a layer 3 switch. Now, a couple of VLAN notes and a little bit of troubleshooting thoughts. Creating a VLAN and adding ports is different than working with a VLAN interface, right? So you saw that I added a port to VLANs in a couple of ways, and then I could go to that VLAN in the configuration. But of course, there's also the interface in a VLAN. So the interface in a VLAN can also be used to shut down a VLAN or bring a VLAN back up. You can also go to the VLAN commands and say no to a VLAN. And so these are all things that the sort of accessing the VLAN in a different way, or accessing or controlling different aspects of the VLAN. So that's important to remember. And I think this is actually one of the questions in the "Do you know this already" section of the chapter. What happens when you shut down or delete a VLAN? So some troubleshooting things, right? Remember that you can do the show VLANs. You can take a look at the interface. You can do a show int VLAN 11 in this case and see whether or not it's up. You can see whether or not you've got IP routing enabled. Is the port connected to the VLAN also up? So these are all things to worry about. Think about what you're doing with your trunking commands. Are you pruning VLAN somewhere? What is spanning tree doing, right? Did spanning tree shut off one of your interfaces or block one of your ports? These are all things to think about when you are building a more complex topology. All right, now this is where things get a little crazy, right? Now we're going to say, well, what if I want to route with a switch to a different sort of interface, right? What if I want to connect a switch to a router? Is there a way for me to do that without doing the switch virtual interfaces? And so what we're going to do is make a switch port act like a router port. This is different than the switch virtual interface. When you do that, it behaves just like a router interface, right? It looks only at the layer 3 header, just like a router would, right? It understands that it's my MAC address, but it's going to examine things at a different layer. When it needs to forward something, it will create a new Ethernet header and frame for forwarding. Now the configuration is pretty straightforward. We're just going to do a no switch port. In effect, turning off all of the switching for that particular port and then giving it an IP address. Now, while we're talking about this, we're going to add in this idea of ether channel. Now, if we remember ether channels, when we are building more complex topologies, let's say you're talking about a data center, or you're aggregating traffic through a bunch of switches, or you want redundancy of some kind, we built layer 2 ether channels. And there are a couple of important ideas there. One is that the two sides have to be configured to do the same thing, right? The same link aggregation control protocol. They had to have the same configuration and speed and duplex, right? These are all really important. And that was way back in channel 10. The same rules apply when we're at layer 3. The difference is that now we're going to be dealing with routed ports instead of layer 2 ports. And we're going to be putting an IP address somewhere. So that's kind of important to us. So the configuration is very similar, at least for the first part of it, but then we're going to add some stuff. Now I added a couple of pictures here. The top picture, switches 6 and 7, that shows what happens if you just connect a couple of switches to each other with more than one link. And what spanning tree does is it kills off one of those ports, right? It blocks one of the ports. But switches 4 and 5 there, those have an ether channel, a layer 2 ether channel configured on them. And so now spanning tree thinks of them as the same thing, right? And that's where we make a port group out of a channel group, right? So each port is added to a channel group that creates a port group. For a multi-layer switch, what we're going to do is the same thing, but we're going to say, well, let's use routed ports to do it. Now, the nice thing about using routed ports to do that is we get to take advantage of the load balancing that we get when we do aggregation, and we get the IP addressing. So there's nothing at all that says that you can't do the exact same thing with routers that you do when we wanted to connect multiple switches together with multiple links. Now, why wouldn't you just hook up a bunch of routers together? You could do that. You could say, well, that's all right. I'm just going to hook up a whole bunch of routers together, and I'll run multiple connections between the same routers, just like you see in multi-layer switch 1 and multi-layer switch 2. The problem with not creating an ether channel is that now the pathway to destination networks would have 2 routed pathways that it would understand. So you would get routing table growth, but you would also have multiple configuration items to worry about. By creating an ether channel, that pathway now looks like just one route. So that's very handy. It's not as complex, and you get the extra benefit of all of the load balancing stuff that you're going to use with an ether channel. Okay, let's take a look at an example. So we'll take a look at our switches, right? These are just 2 switches with no ether channel configured, and we know what happens. If I do a show spanning tree, I can see that one of the ports is blocked, right? Now I started to configure an ether channel here, but then I said, no, I'm going to do that with different switches, but we can see that one of the ports is blocked. That's why it's amber. But over here, if I do a show interface status, I can see that I've got this port channel configured here. And if I take a look at my configuration, right, I can see that I've got a couple of interfaces in my channel group, which then gives me my port channel. And when I take a look at what spanning tree is doing, spanning tree just says, oh, I've got this one port channel up and I don't have any blocked ports. Okay, so that's layer 2. At layer 3, we have these fellows right here. Now we do the same thing. Do the show run on this first. Now we'll do the part of this that's the same, and then we'll talk about what's different, right? So you can see there's the channel group mode active, and there's the port channel that's created. But there are a couple of important differences here. One is that I did the no switch port command for the port on the switch. That means I want you to behave like a router. Or I want you to behave like a routed port, I should say. And on the port channel now, not on the interfaces. And this is one of the things that I want to point out now because I don't know if I'll remember it when we do the questions. The IP address goes on the port channel right here. And then lastly, we have to do IP routing because this is a multi-layer switch. Now, I did the same thing on this side and I gave an IP address to the port channels, and maybe I'll do this. This is the example that's in the book, by the way. I think it's 1.21. I'll check here and again. It's 10.1.21.2, I think. But we'll take a look at, we'll take a look at a couple things here. Because I turned on IP routing, and this is a multi-layer switch, we know what I get is the routing table. So I can do a show IP route. And I can see that the 10.1.12 net is actually connected to the port channel. So I gotta, suppose I should fix these. We'll make that 12. There we go. And now, because my port channel is up, I can now ping between the two sides. There we go. So that's our configuration for a layer 3 Ether channel. Again, the differences are that I'm doing IP routing globally on the switch, that I give an IP address to the port channel, and because these are switches now that we want to use routed interfaces, then I'm going to say no switch port. Now there's a couple things going on that I'll also point out, right? I didn't have to use an Ether channel to do this. I could have just said, listen, this particular port, I want to do no switch port on it and just use it as a routed port. I could absolutely do that. And in this case, I've said, well, what if we were working with a larger topology like a data center? Then I would use an Ether channel to go along with it. But there we have it. There is a layer 3 Ether channel with multi-layer switching, IP address on the port channel, and the ability to use switch ports as routed ports. So this slide just shows some of the output and some of the configuration that we just did, so that if you don't want to listen to all the narration here, you can just get this in one-stop shopping. Again, the IP address on the port channel that we've got, each port is part of the channel group. We get a routed entry here. We have IP routing globally. Now, the last thing that we're going to do as far as routing goes is that we are going to use a router with integrated switch ports. And what this means is that we're going to add a module to the router. So far, we've turned a router port into a trunk so that it can talk to a switch that's a trunk port. And we've turned a switch port into a routed interface. So now we're going to add another component or another tool in our toolbox. When we add a module to the router, it acts just like, or the ports that are part of that module act just like any other switch port, and they can be identified by their location and port number. By that I mean that when you're trying to figure out what your ports are, this module that goes in here has a particular slot in the router, and the router then will identify the ports by that location and then by their number here. So let's see what that's like. Now here is something that we talked about last time, right? An integrated services router. And what I'm going to do is we'll zoom in a little bit And we can see that I've already installed a module here. So if I take that out, right, I've got these two slots here. So I'm just going to put in this NIM, right, the ES2.4, and we can actually put a pair of them in there. And I'll turn the router back on. You can't do this when the router is running. And if we watch it boot up real quick, what we'll see is that we have a bunch of ports. Now, on the physical box, we know that we have these gig interfaces, right? So G0/1 and G0/0 are my gig ports. And actually, they'll be G001 and 000. And now the question is, first of all, what will these be? So let's take a look. Now you can see that I've got these G01/0, G11, G12, and G13. So that was that. So right here is indicating the location in the chassis, the second number there. And we've also got 020, 021, 022, and 023. So that gives us how we would understand what those ports are going to be. So we'll do a couple things with our configuration. The first up is we will say I'm going to connect port 1, and maybe what we'll do is, so there's our two router ports, and here I'll go to and maybe to remember what we did. This first connection is going to be G010 like that. This first connection is F0/0 or 01. All right, and maybe we'll hook up a PC to port 2. And what I'm going to do on the switch is I'm going to add both of those to a particular VLAN. So I'm going to say config T interface range F0/1 to 2. Just say switch port access VLAN 11, just like we've been doing before. But now what I'm going to do is come over here to the router, and I'm going to say config T int G01/0 switch port access VLAN 11. And then I'm going to do the same thing with G0/1. Now, because I have this switch module, I can say show VLAN over here. Whoops. And we can see that I've added to VLAN 11 these guys here, which also means that I can take a PC and connect it to the other VLAN port, which was .1, and then 192.168.11. We'll make this one .1. And I'm not even going to bother with the default gateway right now because they're just going to be layer 2 connectivity because they're on the same network. So now we'll do 11.2, and we're waiting for that to come up, but I'll set up the command. I'm just going to try and ping between the two of them. Right, they're on, normally it looks like a router and it should be a different network. But is it? Because remember that I've just installed these switch ports, and so they should act just like a switch port, putting them all on the same network. And presto, they did. So that for that module there, it behaves exactly like a switch set of interfaces that you would have on any other switch. All right, and maybe what I'll do is just to show you the extent to which we can work with this. Maybe we'll throw one other, we'll do a, just for fun, we'll do a crossover cable. And I'll go to 2.3 here. Right now, the logic is smart enough to figure out which kind of cable I'm using, but if I wanted to be, a purist about this, right, I could use crossover cables because it's switch to switch ports. And all that I'm going to do now is I'm going to say, well, can I do trunk stuff? So I'm going to say int G0/2/3, and I'm going to say switch port mode trunk. Did it take it? Did it like that? And then I'm going to go right down here and do the exact same thing. right? Because we're going to be really specific. It's saying inconsistent port type. Well, I'm going to fix that. Interface F0/24 switch port mode trunk. And there we have it. So this shows you that you can do the same thing with those ports that you did on any other switch that you have. And so there I've just made them part of a VLAN, and then I've done the trunking too. So there we go. Now the integrated services router, right? Remember, this is for usually the SOHO market. I wouldn't want to do this in an enterprise environment, but I could do an awful lot with this that would allow me to have all kinds of different kinds of connectivity with my nodes. Well, there we go. There is installing switch modules and using switch ports in a router to get this done. All right, the do you know this already or do I know this already questions. Question number 1, router 1 has a fast Ethernet interface 0/0 with an IP address of 10.1.1.1. The interface is connected to a switch. Okay, I get that so far. This connection is then migrated to use trunking. Okay, which of the following commands could be part of a valid configuration for router 1's F0/0 interface, assuming the trunk uses VLAN 4 as one of the supported VLANs? All right, so this is all about router on a stick, right? And so the two things that we need to do is we need to have a subinterface, and we would use the encapsulation command. Router number 1 has a router on the stick configuration, okay, with two subinterfaces. G01.1 and G01.2. The physical interface is currently in the down state. That is no bueno right there. That is not going to be helpful for us. The network engineer then configures a shutdown command when the interface configuration for the subinterface 1.1 and a no shutdown command when the interface configuration mode is for G01.2 subinterface. Which answers are correct about the interface state for the subinterfaces? Well, it's pretty straightforward. Wherever you issued the shutdown, that's going to be administratively down. And G0/1.1 is going to be down because the physical interface is down. Question number 3, a layer 3 switch has been configured to route IP packets between VLANs 1, 2, and 3 using switch virtual interfaces. So this is the multi-layer switch configuration. And then we've got some subnets here, the 1, the 2, and the 3 net respectively, /25, that's the key. That was one of the answers in there to trick you into using the wrong subnet. The engineer issues a show IP route connected command on the layer 3 switch consisting of connected routes. All right, so there's going to be 3 of them. Which of the following answers lists a piece of information that could be in at least one of the routes? The route would be connected to an interface that was VLAN 2. That was the only one that matched. And that should make sense to you. All 3 of these would be directly connected routes to a particular VLAN. So if you were going to write down what the routing table looked like on paper, you would see that appear somewhere. Question number 4, an engineer has successfully configured a layer 3 switch with switch virtual interfaces for VLANs 2 and 3 with auto state enabled by default. Hosts in the subnets using VLANs 2 and 3 can ping each other with the layer switch routing the packets. All right, pretty straightforward so far. The next week, the network engineer receives a call that those same users can no longer ping each other. The problem is with the layer 3 switching function. If the problem is with the layer 3 switching function, which of the following could have caused the problem? Well, if somebody deleted the VLAN, that would cause a problem, or if somebody shut down the VLAN. The other ones didn't match because they weren't applied to these particular VLANs. Question number 5, a LAN design uses a layer 3 ether channel, okay, between 2 switches, switch 1 and switch 2, with port channel interface 1 used on both switches. Switch 1 uses ports G0/1, 2, 3, and 4 in the channel. Which of the following is true about switch 1's configuration to enable the channel to route IPv4 packets correctly? Well, we know that the IP address has to be on the port channel. And then it says this, I have an asterisk next to this one, the port channel is no switch port. Actually, as we saw from the configuration, you would use no switch port, but it would actually be on all the gig interfaces, right? Because we would tell them that we want them to be routed. So that may have been an oops in the book, or I may be reading the question wrong. But the key is that we're going to be no switch port because we want them to be routed ports, and the IP address will be on the port channel. Question number 6, a LAN design uses layer 3 ether channel between two switches. Okay, same idea, switch 1 and switch 2. An engineer adds switch 1 gig port to the channel successfully, but later fails when trying to do the same thing with 0/2. Which answers list a configuration setting on port G0/2 that will cause the issue? Choose 2. Well, one of these goes all the way back to an earlier chapter. You can't put up an ether channel when there's a different configuration between the two sides. So they have to be the same duplex and same speed. And remember that you're going to do the switch port or the no switch port. So if you did no switch port on one and you didn't do that on the other, that would cause the error as well. Question number 7. A router has some routed and some switched physical ports. Okay, which interface subcommands would you expect to be supported only on the switch ports? Well, switch port access for the VLAN. That's the one that we need. Everything else was either in both of them or specific to routed. Well, that was Chapter 18. The Chapter 19 look ahead. We're going to be looking at some host side stuff. Now, we talked a little bit about host routing, but this time we're going to be talking about addressing for the host, parameters on the host, but we're going to also talk about dynamic host configuration protocol and DHCP relay, and then the domain name system, at least as it applies to hosts. Well, this has been Chapter 18, routing in the LAN. Oh my goodness, so many ways to route in the LAN, right? We can route from straight up router interfaces down to VLANs. That's expensive. We can do switch virtual interfaces. We can do routed ports on a switch. We can do switch ports on a router. We can trunk to a router on a stick. We can add modules to a router. So many ways to do that. And don't forget about those ether channels. We did them at layer 2 to increase capacity or aggregation, do some load balancing, redundancy, but now we can do that at layer 3. And we discovered that while we might connect multiple links between routers, maybe ether channels are a better fit because we don't have as many routed interfaces, as many pathways to the same destination, and we get the load balancing. Now, we saw also in this chapter that some of the questions asked you about configuration items and output of commands. So that's an important thing to realize when you're studying for the exam, that you have to be wary of not just how to do things, but what are the configuration items that you're going to deal with, and what is the output going to look like? What are some errors that you might see, or what might appear in a routing table? All right, well, thanks for watching. Thanks for listening. Like and subscribe if you really dig routing. May those packets always reach their destinations, no matter how you're doing your routing. And hey, this is Routing in the LAN via CCNA. You can do this.